Okay, chapter 3 was systems of equations. And so again, I just want to kind of show you my work here so you can check your work. Substitution, elimination are our two methods. There's no right or wrong method. It's just what works for you. And so I'm a big elimination fan. So on number 16 here, I multiplied this top equation by 2 and wrote it down here. And remember, I like to add my equations. So I like to make these be the opposite signs. If they're the same signs, you have to subtract. So then I added these and I got x equals 2. But remember, the point of solving a system is to find the point where they intersect. So I had to take that and plug 2 back in to find out what y was. And so you can plug it in wherever you want. I plugged it in right here in the top equation, and I got that x equals 2 and y equals 4. If it's correct, it should work in both equations, okay? And so 17 is just another one of those. On this one, I noticed like they just had to change the order here, but the y's were already the same number, so I didn't have to multiply. I just had to subtract everything. And so I made that minus x plus 2y and minus 12. So then I got x equals negative 2. Again, I plugged that back in to get the y value that that goes with it. So negative 2, negative 7. Story problems, figure out your two variables, write your equations, and then do substitution or elimination. So in this one, I used N for the price of a notebook and P for the price of a pen. So 3 notebooks and 5 pens cost $13.75, and a notebook was $1.25 more than a pen. So that's where my equations came from. I did substitution on this one. Because N was already solved for, I just replaced N up here in this equation, and then I solved that equation. Definitely more than one way to solve that. Definitely you could probably guess and check, but if you have to write the equations, then that's worth points too. And again, I plug that back in to find the price of the other one. So I got pens were $1.25 and notebooks were $2.50. I think, yeah, my page 2 is on a different one, so I'm going to skip over here. 21, inequalities, solving a system of inequalities. Remember that you just graph both of them, and then you find where the shading overlaps. So you can kind of see my shading is light here, but where the shading overlaps is right here. Make sure you pay attention whether it's dotted lines or solid lines. 23, I had to put this one in slope-intercept form first to graph it. And so this one was x plus 3. So y-intercept of 3 up 1 over 1. This one I divided by 2, and I got a y-intercept of negative 5/2, or that's negative 2.5. So when I go up 1 over 2, it's not going to be crossing at exact points on there. But the good news is you're just finding the overlap of the shading. And this one kind of almost went off my graph here. But this one's going to go down, and this one's going to keep going like this. And they should overlap over here. 29 is 3 equations and 3 variables. We did this. It's going to be hard just to kind of follow my work. But remember that you have to solve for all 3 letters. It's like 3-dimensional, like x, y, and z plane. This one wasn't so bad because there's no y in this first equation. So I was able to I don't even know what I did looking at my work here. I don't know. I multiplied this by 2. And so then I had 6x minus 2y plus 10z and 4x plus 2y plus 3z. That must have been the other one they gave to me. And I was able to get this one with just x and z. Oh, yeah, okay, so that's what I did. So they had these 2 equations I put together first. Then they had this original equation had x and z in it. So that's why I got this one to x and z. So then I could go down here and do this, and I got x equals 5. You could have also solved for z right away in this first equation and plugged in over here and had an equation in just x and y. This is one that just takes some practice, and you just really have to be careful with your work. And then once I got x as my answer, I plugged over here to get z. Once I got z as my answer, I plugged over here to get y. Again, when you get your answers, it should work in all 3 of the original equations. Okay, I think that's it.